Hello and welcome to a new episode of the Python Coding Challenge series. After presenting the concept of truncatable primes in last week's video, I set you all a challenge. Find the first 7 fully truncatable primes greater than 100. I hope you gave this challenge a try. If not, then check out the video linked above and see if you can solve the challenge first. For all of you who gave it a go, here is my solution. As you can see, on the left-hand side, I've already started by writing a function which calculates whether a number is prime or not. If we go through it quickly, in the first part we automatically exclude all numbers which are smaller or equal to 1, because we know that those are not prime. Then we take all values between 2 and the square root of the number we are analyzing, and if any of these are divisors of the number in question, then we return false. Else it means that our number is greater than 1 and is not divisible by any value other than itself. This is exactly what a prime is, and therefore we can return true. Now we have to write a function to calculate whether a number is truncatable or not. We can first of all say def truncatable n, and then say digits equals list of string of n. Then we set up 2 counters, one for the left truncatable and one for the right. We can say left equals 0 and right equals 0. Now we can be a little bit sophisticated and use a single for loop and say for I in range len digits, and then we say a equals int integer of empty string dot join digits of I to len digits. Then we say b equals integer of, again, empty string dot join digits from 0 to I plus 1. Now what this will do is a will be our left truncated value and b will be our right truncated value. So we can say if prime test, which is our function we wrote earlier, of a, so if that is true, then left, our left counter, can be incremented by 1. Also, if prime test of b, then our right counter can be incremented by 1. So just to recap, what this is doing is truncating our number, rejoining its remaining digits, and calculating whether the number we have obtained is prime. This occurs simultaneously for both left truncating and right truncating. If either are true, then we increment the respective counter by 1. Finally, we can say that if the number is fully truncatable, then the left counter will be equal to the right counter, as well as both of these being equal to the length of our number. So we can write return left equals right equals len digits. Finally, we can set up an empty list called res to collect our results. Then we can initiate our first value, which we can call a, at 101, since we know that 100 is for sure not prime. Then we write while len of res is smaller than 7, we can say if truncatable of A, then res dot append A. And then, of course, we write A plus equals 2. However, why would I increment it by 2 and skip numbers? Well, this is because we know that even numbers are for sure not prime. So, by starting with an odd number, i.e. 101, and adding 2 each time, we are only analyzing odd values. This is actually a small example of a very neat set of tricks which expert coders implement to save computational time, since these days a piece of code should not only be reliable, but also extremely efficient. Finally, we can now simply write print res. And if we run our code by pressing the F5 key, we can see that on the right-hand side we have our result. If you also got these values, then congratulations! You have successfully completed the challenge. As always, don't forget to leave a like, share the video, and subscribe to the channel. Also, make sure to check out my other coding challenges and Python tutorial videos. I've left a link to them for you in the top right-hand corner of your screen and in the video description. With that, I look forward to seeing you all in next week's video. And until then, happy coding!